Welcome to the deep dive. Ever stop and think about how your body actually manages energy? It's pretty amazing stuff.
It really is.
Today we're diving into the hormones behind it all, specifically blood sugar balance.
That's right. We're looking at some clear info on metabolic hormones. The goal is, to break down who the key players are.
What happens right after you eat versus when you haven't eaten for a while.
Exactly. How your body keeps that blood glucose level steady.
Okay, let's start there then. Post-meal. You've eaten, blood sugar's up. What's step one?
Well, that rise in blood glucose, that's the signal. Your pancreas gets it and releases insulin.
Insulin, okay.
Think of insulin as the manager when you're well fed. It's a big job. Get that glucose out of your blood and into your cells.
So it's like insulin is unlocking the doors to muscles and fat tissue, letting the glucose in.
Precisely. Unlocks the doors.
Ah.
But it does a bit more, too.
Oh, yeah.
Yeah, in your liver and muscles, it triggers storing glucose. That's glycogen.
Your energy savings account, sort of.
Kind of, yeah. Your quick access savings. And it pushes those cells to use glucose for energy right away. And importantly, it tells the liver, hey, stop releasing stored glucose.
Because there's plenty coming in already. Makes sense.
Right. No need to dip into reserves just yet.
And what about longer-term storage? Fat.
Good point. In fat tissue, insulin helps turn extra glucose into fat, for the long haul. And it also stops the breakdown of fat that's already stored. So insulin is really all about store mode.
And the brain, huge energy user. Is it just soaking up glucose then?
Absolutely. In this well-fed state, the brain loves glucose. It burns it completely for fuel. Powers everything.
Okay, so that's the picture after a meal. Smooth sailing. But what happens when blood sugar dips, say, between meals or overnight?
Right, that dip is the next signal. This time the pancreas releases a different hormone. Glucagon.
Glucagon, the opposite of insulin, basically.
In many ways, yes. If insulin says store, glucagon says release.
It's not just glucagon, though, is it? I feel like there are others involved when things get low.
You're absolutely right. Your brain picks up on that falling glucose, too. It signals the adrenal glands.
Adrenal glands. That means adrenaline.
Yep. Epinephrine, that's adrenaline, and the norepinephrine, plus cortisol. They're like the backup crew.
The cavalry coming in.
Yeah. To make sure you don't run out of fuel.
So what do glucagon and this backup crew actually do?
Okay, so in the liver, glucagon and epinephrine team up. They tell it to break down that stored glycogen back into glucose.
Releasing the savings.
Exactly. And they also start making new glucose from other stuff. That's gluconeogenesis.
Fancy word for making new sugar.
Pretty much. And the liver pushes this glucose, plus some ketone bodies, another fuel source, out into the blood.
Ketone bodies. Okay. And what about muscles in the liver itself? Are they still using glucose?
Good question. They actually start to switch fuels. They begin burning fatty acids.